We present an optimization-based approach that considers a trainee's performance and eagerness to adaptively generate virtual reality training sessions. Many companies start to use VR as a supplement to their workplace training. Designing VR training is non-trivial. It required expertise in the domain, and it should be flexible enough to adjust teaching methods based on the learning status of students and teaching materials. A lack of research focuses on using VR to create an adaptive learning environment or enable psychomotor learning developments. Thus, we use restaurant service training as a showcase for workflow training. Then, our optimization-based approach can adaptively train trainees to develop restaurant skills and practice multitasking in a virtual restaurant setting. Here is the overview of our approach. We first obtain a trainee's performance from the current training session, which includes the number of hints asked, the number of mistakes made on the walking path, and so on. Then our optimizer generates the next training session by solving the multi-objectives optimization problem. Specifically, the output of optimization includes a set of tasks with suitable difficulty for the next training sessions. We created a virtual restaurant that contains 4 tables, 1 kitchen counter, and 1 cashier area. For this virtual restaurant, we design 8 tasks to represent major customer requests restaurant staff need to handle in their daily work routine. The trainee uses the left-hand controller for switching tools between a food tray, a clean-up tool, and a notepad. The trainee also uses an interaction panel to interact with customers. Once the trainee's speech is recognized and matches with the current task's desired response, the customer will respond or react. Here is an example.
What can I do for you?
We want to start order.
What would you like to order?
I want to try noodle and ice cream, thanks.
Sure, and for you?
I want to try chicken leg and chocolate cake, thanks.
We consider 4 objectives in generating the next training session. First, we have repeated mistake avoidance objective to let trainee practice more if he repeated made mistakes. We have familiarity of workflow objective to evaluate whether the trainee understands and remembers HTE workflow of a task. The tolerance of repetition objective to balance repetition and the trainee's interests during training. The eagerness to learn objective to review occasionally played tasks to reinforce their learning. We also introduce a set of constraints to avoid duplicated tasks, limit training session length, and most importantly to increase multitasking training difficulty. We use mixed integer programming to solve this multi-objective problem. We validate our approach through 2 experimental studies. In one of the experiments, we conduct a virtual reality training experiment. The goal of this experiment is to evaluate not only mastery of individual restaurant tasks but also trainees' ability to apply multitasking strategies. We recruited 26 participants and randomly separated them into 2 conditions. We first gave a warm-up session for participants to familiar with the virtual environment and the controls. Then we give a pre-evaluation session for participants to evaluate their background knowledge of serving in a restaurant. Participants can practice the skills for 5 training iterations. In the end, we give a post-evaluation session that has the exact same task as in the pre-evaluation to the participants. We also ask them to fill out questionnaires after completing post-evaluation. Here we show trainee performances in terms of the final score in pre-evaluation and post-evaluation trained by the adaptive training approach and the random assignment approach. The amount of improvement by each approach is also shown. Participants from the adaptive training approach receive higher final score than those from random assignment approach. In our second study, we perform a simulation experiment. The goal of this experiment is to determine whether our approach can train people more efficiently compared to other approaches given a steadily improving trainee as input. We compared our approach with a random assignment approach and a performance-only MIP approach. For more details, please refer to our paper. As a result, trainee taking the performance-only MIP approach training has the most improvement for all tasks in all 3. The trainee taking the MIP approach has better improvement than when taking random assignment training approach. This is the end of our video. Thank you for watching.